Hello, everyone, and welcome. My name is Jessica Williams, Programs and Community Partnerships Manager at Chabot Space and Science Center, and we are thrilled to bring you another live program to your homes this evening. Tonight, we have the honor of bringing you this program with the SETI Institute, and we have Dr. Margaret Race, who will be telling us what it might be like to celebrate Thanksgiving on Mars. First, I'd like to introduce to you all Dr. Simon Steele, who will tell us a little bit more about the SETI Institute. Welcome, Simon.
Thank you, Jessica. Good evening, everybody. It's great to be here for the fourth Talks for Families brought jointly by the SETI Institute and Chabot Space and Science Center. For those of you not familiar with the SETI Institute, we are a nonprofit research institute based in Mountain View, California, across the bay from Chabot. It is an institute dedicated to the search for life in the universe, and life in the universe in all its forms, from microbes on Mars to advanced alien civilizations. So it's a pleasure to welcome one of our research scientists tonight, Dr. Margaret Race. So we're going to spend Thanksgiving on Mars tonight, which is going to be very nice. I hope there's turkey. Just a couple of announcements. On December the 8th, we will have our fifth in the series of Talks for Families, and Dr. Frank Machis, Senior Planetary Astronomer at the SETI Institute, is going to give us a grand tour of remarkable exoplanets. So that is coming up next month, and we'll have lots of warning and lots of advertisements for that coming up, but that's one not to miss as well. I would like to ask you as well, we're going to have a survey at the end of this talk. Let us know what you think. It's very important to us to get feedback as we continue this, this series that we hope is going to run well into 2021 and beyond. So without further ado, I'm going to hand over to Jessica and Margaret.
Thank you, Simon, and thank you to the SETI Institute. These talks have been amazing and so wonderful to hear from all of your wonderful scientists and what's happening out there in space. So thank you so much, and we're looking forward to doing more with you all. And now I would love to introduce you all to Dr. Margaret Race. Dr. Race has worked with NASA and the SETI Institute for nearly 3 decades on research and education related to Mars missions, planetary protection, and astrobiology. She initially studied marine biology and ecology, analyzing the impacts of invasive species in tidal wetlands in the San Francisco Bay. Over the years, she has applied her interdisciplinary background to diverse real-world challenges, from water pollution and coastal zone management to space missions and searches for ET life, and even decision-making about pandemics, biosafety, and our collective future on this planet and beyond. Join her on this talk on planning for Thanksgiving on Mars, and maybe someday it'll be more than a hypothetical exercise. Dr. Race, thank you so much for being with us today. And if anyone has questions for Dr. Race, please be sure to post them in the chat. We'll get to them afterwards. Thank you so much for joining us. Happy to have you.
Oh, great to be here. I remember my first experience with Chabot. You weren't even built as a planetarium up on the mountain yet, on the hills. So one thing I like about Chabot and other great organizations that have planetariums and organisms of all sorts and art and everything else is that it makes us stop and think about what we're doing and how we use technology, how our lives are different than maybe in the past and could be different again in the future. And so in talking about Thanksgiving on Mars, it's a way to look at exploration and human missions beyond the planet Earth, and maybe where else we can think about life elsewhere in the solar system, perhaps the galaxy or beyond. Next slide. So, back one. So when we're planning, back one slide. When we're planning the missions to Mars, okay, go ahead, and we're thinking about borrowing from the past, because we're talking about what is Thanksgiving and what is it like in different countries or cultures. We want to plan ahead, because if we go to Thanksgiving on another planet, it certainly may have some restrictions, just as flights in the International Space Station are different than here. We're thinking outside of the box, not just our own American perspective, but many other countries are also involved in space exploration and perhaps even commercial activities as we go forward. But we have to be realistic, build it on the science, think about stretching ourselves a little bit, but recognize that we're in it with lots of other people. So if you look at the picture down below, the journey to Mars, Earth is on the left. Don't know if you can notice it, but International Space Station is just up underneath the word journey. The moon is a little bit further out. It's down at the bottom there. And then Mars is much further out. And you can see there's lots of missions, lots of activity, and we're learning about things that involve science, technology, and lots of other things as we think forward. So next slide. So what I'm going to do is start with the idea of Thanksgiving. What is it based on? Where do we celebrate it? What's involved? And how does it compare in different places? I'll look at Thanksgiving now. Thanksgiving's with the Pilgrims, because that's sort of where it all started, and the future. What would be Thanksgiving beyond Earth? What would astronauts do? What would other folks think about? And in looking at that, we'll be considering how you plan human missions. You have to build on data and information that come from robotic missions and space missions, as well as technology here on Earth. And we're integrating the advances in science, technologies, policies, and just about every kind of career that we can think of. And we're asking, what would it be like to live somewhere else? In many ways, this is not that different from the Pilgrims when they first came to the New World, as they called it, and or the pioneers coming out to California from back east. And we're using science as we do it. Science is everywhere around it, and it's not something that is just static. And I maintain that everyone is a science. When you are born as a baby, you have curiosity, you touch things, you push things, you use your senses. And then you don't just learn it out of a book, it's a process. You're learning all the time. When you put a little bit more mayonnaise in that salad, it comes too gloppy, or, you know, maybe you want to put something with more or less water, or a tool with that doesn't have to be built here, it could be 3D printed. So we're always improving. And for the young folks in the audience, I would like to say that I like the book Dr. Seuss wrote on, Oh, the Places You'll Go, because you can do anything. How else would a marine biologist like me end up working with NASA on issues that have to do with environment elsewhere? And we'll need people that can cook. We'll need people that can make movies of it. We'll need people that can make rockets and technology. So let's go on and talk about Thanksgiving on Mars. Next slide. So whenever you're planning a trip, you really have to say, well, where am I? What's my current location? And what's my destination? And in order to really think about that, the biologist in me learned a lot of these things along the way. How do you put the solar system and Mars in context? And considering sizes and distances of what we see out there in the sky at night is really of interest to, of course, astronomers, but let me put it in terms that anyone can understand. Next slide. So for me, it kind of dawned on me when I found a small thing when I was actually going into classrooms in Berkeley and Oakland when my children were growing up. And it's made sense. If you consider the size of the universe, the visible universe, and every star out there is represented by one single grain of sand. Our sun and our solar system are there with the first grain of sand, our sun. All the stars you would see on a starry night would fit inside of a thimble full of sand. All the stars in the Milky Way, our home galaxy, a very large place, would fill a construction-sized wheelbarrow. And all the stars in the known universe, the visible known universe, would take railroad hopper cars being filled 1 per second, 24 hours a day for 3 years. So when we're considering a trip into space and having Thanksgiving on Mars, we barely left the front porch. But anyway, it's still pretty far. Next slide. So as I said, for each star out there, they can have many planets, just as our single star, our sun, has many planets. And what we're interested in, the biologists and others at SETI Institute and elsewhere who are looking for evidence of life out there, we're interested in potentially habitable planets. Now, a habitable planet is something that is not too close to the sun or star that it would cook, be so hot that life couldn't exist, but not so far away that it would be so cold that life couldn't exist. So we're looking for planets that are potentially habitable. And honestly, the first extrasolar planets outside of our own solar system that we discovered were discovered only in around 1995. Got verifiable information that yes, there are planets going around those other stars. And so they started adding 1, 2, 100. Well, just this month, Science Magazine, November issue, put out an article estimating that there are over 300 million potentially habitable planets in just the Milky Way, our home galaxy. That's the construction size wheelbarrow. And that is using data from the Kepler Space Telescope, which you can see in this slide here. The area that the Kepler telescope searches is not even much of the Milky Way galaxy. And so what we're thinking is now Earth-sized planets that orbit their sun in the galaxy that have conditions warm enough, not too close, not too far away, to have liquid water on the surface or someplace on the planet. That is a place that we would look. So right now we have got estimates that the potential out there is incredible. And basically what we know about life is life as we know it, you and me, and microbes like the coronavirus or all sorts of invertebrates, earthworms, clams, mud snails, anything that is alive. And it's all made up of DNA. And it also has liquid water, and it has to have the right conditions. So there's a lot of it out there. And the idea with SETI and other searches is that if we're looking at those kind of conditions, looking at the places out there just in the Milky Way that have the conditions that can be suitable for life, then it's likely we do have company out there when you consider the whole universe. Next slide. So we're coming back into the solar system. We're just going to we are the third planet out, Earth, and Mars is the fourth. So we're just going to the nearest neighbor in there in the solar system. Next slide. So in planning our mission, I would like you to think also about where are we and what do we consider for Thanksgiving? So just in your mind, conjure up a couple of things. When I say Thanksgiving, what do you think about? Take about 10 seconds and let you just pull that together. Okay, hold it in your head. And now I'm assuming that we'll all have a Thanksgiving of some sort in a very short while. So go to the next slide. So family Thanksgiving probably looks something like the photograph here, a little bit of everything. It's a very special day. And so if I asked you to write down what was involved, some of you probably said a turkey or a family gathering, certainly a special holiday. In my family, we used to take out the good china, the special plates. We set the table with a tablecloth, not something you do every day. Of course, lots of food and drinks. But there's other things you probably didn't think about. Where is it? Where are you going to celebrate it? Are you staying at home? Or are you going to grandmom's house? Or are you going to get together with your neighbors? How are you going to get there? Will you walk or take a car? Will you take a train or maybe even fly someplace, even with the COVID situation like it is? How many people will you go along with and how many will be at the table? That may make a difference on how big a vehicle you need. Will you stop along the way? If you're taking a plane, maybe you will. What kind of supplies and fuel and other things do you need if you're driving your car? So you see, there's a lot of things that go into Thanksgiving that aren't usually just associated with the turkey. What else is needed? Well, you certainly have to put some clothes on, and I hope you shower before you go out. You'll need to get the food ahead of time and think about supplies. Do you have an oven or to cook your turkey? Is there a refrigerator where you can get your ice cubes? Is there heat or light at the place that you're going? Of course, I hope there's bathroom or maybe emergency supplies, a nearby hospital if something goes wrong, or how about a fire? If you might have to deal with that if there's something that is an emergency. And the question too is, how long will you stay? Will you be like the Pilgrims and just go there one way? Or will you do round trip and go back home? And of course, you might want to think of some nice extras. Will there be a TV there to either watch football or think about the Thanksgiving parade? Or will you have music in the background? Maybe decorations, toys for the kids to play with, a high chair if you have a baby. So you can see that when I say Thanksgiving, there's a lot that goes on that we don't necessarily think about, but similarly, we have to do something like that when we go to space. So next slide. So what the planning that is involved is using your current knowledge about Thanksgiving, putting it in a scientific context, science, technology, engineering, and math, thinking about the location and the environments and the nature of the environments that you're going into, and consider the lead time that you have to prepare for all of it. Next slide. So it was fascinating for me to go through some of the reading about Thanksgiving and pilgrims. I grew up in the Boston area, so to me it was just, well, sure, Plymouth Rock. But it turns out that their objective when they set out from Britain was to build a new settlement. And they came to America in the Mayflower, which we've probably all heard about. But did you know that they began building it in 1608? It was only 90 feet long. That's just a little bit longer than the average swimming pool that's outdoors. And they traveled 3,200 miles by sea. They had 100 people on the ship. So if you look at that photograph or the drawing on the lower left, that's a lot of people for a relatively small ship. And all of them had clothes. You had to have sails. You had to have a small boat so you could take people out to the ship. You had to have oars, dried food. They went across the ocean having dried meat and dried beans and other vegetables. They, of course, had barrels of fresh water because they didn't know where they'd get it out in the ocean. Blankets, clothing, all the things you might need to sleep in. So the next slide. The travel time, they were using what they knew and were just making incremental progress. They knew enough about sailing because Columbus went before them to the New World, and people had been sailing in the Mediterranean and around Africa for a very long time. They departed in August of 1620 and arrived in America several months later, just one way. And this year is the 400th anniversary of their trek to the New World, which I hadn't thought about, but here it is. Happy 400th Thanksgiving. They settled, they actually landed at the tip of Cape Cod in Provincetown and kind of took the next 5 weeks or so and just kept coming along and settling. They finally settled at Plymouth, but they had a terrible winter. From 1620 to 21, they had people who died of sicknesses. They had snow. They didn't have food. They were subsistence living off of whatever they could find. And they didn't meet Native Americans until March of 1621. Their first Thanksgiving in America was actually 401 years ago, or no, 399 years ago. And Thanksgiving didn't become a US holiday until 1863, when Abraham Lincoln made it into a holiday. So as you can see, a lot went into it before they could get here and celebrate a holiday. Next slide. Similarly, we have a long-term context for paths to Mars. And NASA kind of puts their path to Mars into 3 stages. Earth reliant, so those are missions that are around Earth, and it only takes hours to get up to the International Space Station, and they're learning about living in space. And US companies are now helping to provide access to low Earth orbit. And just this week, for instance, SpaceX was involved in launching the next crew of astronauts up to the space station. Then we have going a little further out, a proving ground, or maybe Earth dependent, I'll say. Those missions can last 1 to 12 months. And it takes days to get to the moon and days to return. And we've done it before. We did it during the Apollo missions in the late 60s and early 70s. We're expanding our capabilities to visit new other bodies in space, even asteroids, for instance. We might be able to someday go back there, and go to asteroids and mine them for resources. And then the next stage will be to go with larger spacecraft for the astronauts and go out to Mars. those missions actually take 2 to 3 years. It'll take 6 to 9 months, depending what kind of rocket you go in, just to get to Mars. And you cannot do a U-turn and come back, because once you're out there, you'll be traveling along with the planet as it orbits the sun. We orbit the sun once every 12 months. Mars is once every 26 months. So we have to time it, and the missions to Mars are only launched about every 2 years plus. Next slide. So before we go to Mars, we want to build on what we know already from the space station, which, as I said, has been occupied since November, early November of 2000. So this is another anniversary year for Thanksgiving. We are 20 years living with crew in the space station. It's located only about 200 or 300 miles in altitude away from us in what's called low Earth orbit. And the size of it is roughly like a 6-bedroom house. It's not huge, but you can bet when those astronauts arrive at the space station and they climb out into something much bigger than the vehicle that they came in, that feels like it's very spacious to them. And at any one time, there's about 6 crew on board. The space station orbits the Earth every 90 minutes. That gives them 15 orbits a day. And it was made in pieces over many years in cooperation with multiple countries. And so before the crew could go there, in November of 2000, we had been working in the 1990s to build it. Next slide. So already we have had Thanksgiving on the International Space Station. So Thanksgiving in space is something that we can take a look at. So Simon is going to load up the little video that we have. And here we go. How to prepare.
Happy Thanksgiving, everybody.
So one thing that's really interesting, they were eating their Thanksgiving dinner, but if you'll notice, they were in what looks like a garage. It's hardly a very pretty thing to do, and living in space can be very difficult. We're getting better at it, but look at their decorations, a nice little cardboard turkey, and there's their dining room table. So it's tough to think about putting decorations and all of that stuff out there, and even more difficult to think about putting it on the moon, on Mars. Next slide. So for additional planning that goes into distant space travel, we're doing it a lot like Columbus when he headed out to explore and find out what else was out there, the Pilgrims, and I would say the pioneers to Mars. They used different technologies and they covered lots of different distances. So the Pilgrims took 3,200 miles to go across the ocean, and they took about 3 months one way. Pioneers to California, about 3,000 miles overland. They used covered wagons and basically on foot with the help of horses carrying everything else. And they went across the country. It took 5 to 6 months to do that. When we're going to space station, again, 250, 300 miles above us, the missions tend to be 6 months to a year, but it only takes hours to get up there. On the moon, instead, it's 250,000 miles away. A one-way mission is about 6 days, and the mission round trip would take 1 to 2 weeks. And Mars, in contrast, is 50 million miles away. A one-way mission would be 7 to 9 months, depending how fast your rocket is, and a round trip would be 2 to 3 years. So once you head off to Mars, you better be all ready, because you don't come back to Earth to get supplies. Next slide. So as NASA's planning this movement from Earth to Mars, you can see that we're doing it in a stepwise path. International Space Station, then the Moon, and then Mars. And even so, it's a huge amount of distance and a lot of missions that are on that path forward. Next slide. Moving beyond low Earth orbit is something that is in a transition right now. NASA is talking about a transition away from the International Space Station by about 2025. And remember, it's been up there for over 20 years, and the thought is maybe they'll privatize it and develop commercial capabilities for living and thriving in low Earth orbit. It will be a total commercial environment if they do that switch over. And in fact, Elon Musk and others in the SpaceX industry are thinking about, well, maybe tourism, maybe doing things for commercial groups. And so we may see a completely different International Space Station as we go forward. But definitely, if you can see this image, there we are on Earth. There we are with International Space Station in the foreground, Moon further away, but Moon is orbiting us, and then Mars off in the distance. So if we're going to return to the lunar surface, first we want to go there, and that will take till the end of this decade. It'll be another number of years to get there because we have to build a moon base. Next slide. Continuing towards that proving ground or the Earth-dependent place, government and commercial partners are starting to work together. NASA launched a Orion mission in 2020, earlier this year, had no crew on it, and they're anticipating that they'll get to the moon and start to build on the moon a bit, but not with crew, but not until 3, 4, 5 years from now. This week, again, another remarkable launch. It was a commercial crew, the first human commercial crew. It was in a vehicle that wasn't a NASA vehicle. The crew actually had 3 US astronauts plus 1 Japanese astronaut that were in the small Dragon capsule seen at the top of the right-hand photograph. And they had a welcome and post-docking ceremony just last night. It was 1 a.m. Eastern time, and they took over 24 hours to get up to the space station from their launch at Kennedy Space Center. And our next step is to build a lunar orbital platform that will, again, be that part of the transportation to get back to the moon. It'll be in lunar orbit for transit between the Earth and then the lunar surface. And again, like International Space Station, it will take multiple additional missions to establish that lunar base and facilities. So we're taking our first big step beyond low Earth orbit. Next slide. But we already have new bumps in the road. For instance, November 10th this year, not so long ago, a week ago, NASA's Office of Inspector General put out a report that concluded that delays created by changes within NASA's plans for development of the Gateway make it unlikely that the Gateway will be available to support the agency's planned 2024 lunar landing with the Artemis 3 mission. And that was reported November 16th, just yesterday in Space News. We've got a change of administration. And so now we have an announcement that the president-elect, Joe Biden, is coming in January, but NASA's Jim Bridenstine, who is the head of NASA and has been, he's going to step down. And so we'll likely have a new director of NASA. Biden's space plans are still being formulated, and with that goes along with the budget. But already people are saying that it's probably likely that space and NASA and our big exploration missions will probably take a backseat to more urgent missions and issues like the corona pandemic and the economy by itself. So look at this, just this week, the changes that have already happened to the feasibility of getting back and building a moon base. Next slide. It doesn't mean we won't continue. So we're continuing to the moon, thinking about what are the next steps. We'll definitely build on our Apollo program from the 60s and 70s. We'll definitely borrow and build from the International Space Station. So as we go forward, we already say the moon is 250,000 miles away, one way. And it's estimated it'll take 20 plus years to build out a moon base. Just look at the two photographs on the left side. That was Apollo. So everything that went down to the moon, that's what the astronauts came back in. They didn't really have a base. And they did send up some rovers, as you know, and there were golf balls and other things up there, but there wasn't a lot up there. And it took multiple missions to just do the Apollo missions. So if we want to build a base and have solar power, for instance, and places where the astronauts can have a biodome to grow food or have places that they can stretch out a bit, it's going to take a while to build a base up there. Everything has to be sent from Earth. Next slide. So planning to go back just to the moon for Thanksgiving, you have to have usable facilities. They have to, of course, be safe. They have to be fit so that the humans can feel that they're not just sitting there in a cramped space. We need to think about power. Where are you going to get the water? Yes, there's water and ice on the moon, but it probably is going to take some sort of treatment so that it's drinkable. You'll have to bring food up there or perhaps make a biodome of some sort. You have to think about the heat. Where are you going to get your heat? Also, the moon has no atmosphere to speak of, so that we'll have to think about how you're going to make your oxygen to breathe. And everything you do has to combine our experience with both robotic missions and human missions. Perhaps 3D printers can help at some place up there, but obviously it'll take more than just astronauts and rocket scientists to get up there. It'll take all different kind of expertise, which NASA and the international community have working with them. Next slide. What else will they need? Well, you saw the photograph of the Apollo missions. They had spacesuits and they had rovers, but now we're talking about having something that is more durable, more usable. And so a lot of the things that we had from space station and or the moon, we're updating and making them more usable for both the moon and then Mars. Next slide. Here's an example too, where the bottom left, that was going to the moon, and that is artificial life support. That the weight of that whole suit is something that has to be carried on by the astronaut. Of course, in low gravity, that makes it nice, but we're redesigning the spacesuits. When we went to the moon, the spacesuits were exposed to a lot of dust as the astronauts were out on the moon. So think about yourself with something like a zipper or a Velcro fastener of some sort. The dust could get in it and maybe the suit wouldn't last so long. The middle photograph on the bottom is of an astronaut on space station. Remind yourself that we've been up there for 20 years and there's no dirt or dust to worry about when you're floating around in space. So now we have to think about blending the experiences from space station with the ability to go down on a surface and be independent, but you want to have something that is a lot more comfortable, maybe completely made with different materials, and could be something you could wear for a long time. So as we look forward to the 2020s and beyond, you can see the whole spacesuit design is something that has to be worked on. And NASA has even worked with the Fashion Institute of America on some of the discussions about spacesuits. And women's spacesuits fit differently than men's spacesuits, so there's a whole area there. Next slide. And when we think about the Apollo era items, a lot of them still remain on the moon. So there are antennas that are there, thermal shrouds and material, parachutes, radiator systems and fuel tanks, sensors of all sorts, and even bags of diapers. This was in the 60s, if you remember, and NASA was one of the groups that was involved in probably the birth of things like Pampers and early diapers, because the astronauts had to wear those in their spacesuits. So we have to think broadly and improve everything. And it's more than just things or suits or people. We have to address other concerns as well. Next slide. So the Bay Area has a fascinating connection with the Apollo missions, and now as we go forward. When we went to the moon, the USS Hornet, which is docked in Alameda, was actually the system that picked up the astronauts when they landed in the ocean. And if you look at the bottom left slide, that is the astronauts coming off with special biological isolation gear. They had suits that were put on. We didn't know if there was life on the moon at the time we went there. So the astronauts were quarantined. If you look at the middle picture, they were in an Airstream trailer on the Hornet, and they had to stay in quarantine for fully a month. In fact, you can see the actual Apollo 14 Airstream trailer on the Hornet. So the Hornet is actually a visit to both Apollo missions and naval history as well. Next slide. So it's not just food or equipment and technology, but also concern for other things. In the case of the Apollo missions, we did not know if there was life up there. And so we were already being guided by the Outer Space Treaty of 1967. It's a UN treaty that still is important today. There is no sovereignty, no country can claim and take over another body out there in space. There's no militarization of space, a terrific thing. No nuclear weapons, that's what's in the treaty. And the outer space is for peaceful exploration and use for the benefit of humankind. Article 9 is a part of the treaty that says you must avoid harmful cross-contamination of the planets and also any adverse effects on Earth when you come back with things from space. And that is termed planetary protection. There are requirements and policies for avoiding forward contamination. You don't want to bring microbes out to other places on your spacesuit or on your person when you arrive at a new planet, especially if you're looking for life. And back contamination, you definitely want to avoid. You don't want to bring things back to Earth that have maybe biological contamination or life forms that are coming back from the other planet. So there's limitations on what kind of samples and equipment and how you treat people when you bring them back. Next slide. So if you look at it, here's another one where we've got to think forward and plan. When we're in low Earth orbit and geostationary orbit, those are part of Earth. And there are lots of stakeholders and many legal issues that come onto the treaty: liability, harmful interference, rescue of astronauts, access to communications frequencies and orbital assets, satellites, remote sensing, avoiding space debris, and giving launch licenses. But if you'll notice, planetary protection and avoiding contamination is not part of that. When you go to the moon or celestial bodies, it turns out a lot of other things are still up in the air legally, and planetary protection is one of them. What does it mean to go and avoid forward contamination to the moon or Mars or another body in the solar system? Next slide. So there's a duality of regulations. And when we go to Mars, we know we must be Earth independent. Everything that we take along with us has to be put in the spacecraft and brought up there. It's an environment that has a carbon dioxide atmosphere. It's about 1/3 gravity compared to Earth. There's no liquid water that we can see, but there's probably ices. There's no resources. Here we are, no trees, no fish, no anything else to get. And obviously would need artificial life support before we go there. And everything has to be built before humans arrive, just like the moon bases and the International Space Station. Next slide. So that incremental approach actually even caused them to rethink what we're going to do when we go back to the bodies with humans. So we take the Outer Space Treaty to avoid harmful contamination, to make sure that all the countries who sign it do what you're supposed to. You have a policy, in this case, avoiding harmful contamination. That's sort of like thou shalt have clean air or clean water, but then you have to turn those statements, those policies into requirements. How clean? Where do you dispose things? And for COSPAR, the Committee on Space Research, which is a science group, that group has already said in 2008 in some qualitative policies, safeguarding our Earth is the highest planetary protection policy, even before saving the crew. Don't bring things back that could be a problem to Earth. You want to make sure that you control human-associated contamination and understand it. So there's going to be a lot of work with microbes. It will not be possible to entirely keep humans and our activities in closed systems. So what level of contamination and spread of microbes or contaminants is okay for a place like Mars, especially when you're looking for life? And we know that the crew members will invariably be exposed to Martian material. So now that raises questions about what kind of requirements when the astronauts come back. Will they just be able to step off the spacecraft and come home? Or will they have to be some sort of special quarantine like biosafety labs that we have now? Next slide. So long before we think about Thanksgiving on Mars, we're having to blend a science understanding about Earth and humans and Mars. Think about the mission plans and all the missions that we can use to gather information and consider planetary protection. And we have to address this step by step. And what NASA and the international community has done is hold a series of workshops. They're following the water. Where is the water on Mars and can we get at it? Explore habitability. What is the environment like there and what would we have to do to plan our technology to allow humans to live? We're also going to go up there to search for signs of life. How do we contain it? What if we find it? Do we bring it into the habitat with the astronauts? And all of this, even the science on the one-way missions that are up there now, is contributing to preparing for future human exploration. And you can see in the bottom line, that's going from 2000 and into the future. Next slide. Here's some of the workshops that we've had. NASA has sponsored some of them here in the US, even down at NASA Ames Research Center. That incremental path forward started with workshops in 2000, discussions in 2012, and the first workshop was 2015, another in 16, 18, 19, and another one was just held this past May. And each of those has had 85 to 100 attendees, and we have invited people that are focusing on microbial and human health. What kind of things do you have to worry about to keep the astronauts healthy? What kind of technology and operations can you have for contamination control? Think about the masks that we're wearing now and the face shields and things like that. What would be the equivalent of that for when we're up on Mars? And what happens with the natural environment? How does contamination spread on Mars? Dust storms or moving around? So all of that has to go together as we're starting to plan to fill those gaps that we have. Next slide. Already we're filling the gaps on planetary protection by looking at microbial monitoring on the International Space Station environment. There was none of that before. And so they started by saying, what are the microbes associated with humans that we can find inside the space station? And what comes out? So they're sampling outside the vents to see if inside and outside are similar. And where do the microbes and contaminants go? Can we find them a little further from the space station? So they've started to do routine, weekly and systematic surveys of microbes. They're also monitoring the crew themselves. Where are the microbes from humans? And they're routinely adding pre-flight, during flight, weekly, and post-flight studies of the human microbiome. And then it'll be systemic. We're going to look at all the crews on all of the missions that are going to space station and seeing how their microbiology of the human body and all the microbes that are associated with us What are they like before flight, after flight? So we're gathering this big body of information. And we'll be also assessing the cleanliness levels. How clean is it? How clean does it need to be? What are the leak rates? And all of that gives us background information. And one of the highest priorities, and not surprising now when you can think about COVID, external and internal swabbing is the high priority to understand the bioburden, the bioload that we humans carry up there and how it spreads all through the space station. Next slide. Similarly, when we go to Mars, we've got to collect information on the Mars environmental conditions. Where does biological contamination go when it gets outside? And do we need to make special regions up there? Partition the Martian surface and say, this is an area where we want to keep it pristine. We need operation zones where we can have exploration and human-based activities. Commercial activities. Already, we want to find out if someone wants to go up there and do surface mining or resource extraction, what will that do to the environment? And certainly, we want to think about historical areas just as we did on the moon. Do we want to set aside some areas like the first landed materials, the spacecraft that have gone there before, and set those aside as historical preserves? Meteorological data, another huge thing that we have to gather information on. And already on the Mars 2020 mission that launched this year, and the rovers are going to be on the surface in the early 2021, we have instruments to test if oxygen can be produced on Mars, and even studies of spacesuit materials and the visor materials. How will they last on Mars compared to going outside in space stations? So there's lots of things that have to be done. So test swabs of fabrics, test swabs of visors have to be made as well. Next slide. So here's another one. We're doing it internationally too. This is samples of Mars sample return. We'd like to get materials from Mars back to Earth so we can study them. The first little the first little mission that you could see was the NASA one that went up with a rover that's going, the Perseverance rover that is on its way to collect samples and leave them up there. Then the Europeans will come up and land, and there'll be another rover, and they will collect those samples and bring them back home. So there's going to be all sorts of missions that have to coordinate in order for us to bring samples home. And that doesn't count what we're going to do with the samples when we get back home. Where's the biosafety lab that will put them in? Next slide. Here's some of the rovers that the Europeans are going to be launching, and they have instruments on them to perform terrain mapping. They're going to look at mineralogical composition of the surface materials, close-up color images of rocks and outcrops, ground penetrating radar to look at the stratigraphy, the geology under the rover and determine if there's water in any of that, to look at the mineralogy and the rock formations, and to consider the composition and of the surface materials and see if there's organic pigments or materials that might be associated with life. So all of these things are starting to work together, and it takes a long time. So next slide. And again, we have to think about building all of those things we spoke about before, constructing things, making sure we've got supplies and food, waste disposal, where you're going to put things, surface mobility and vehicles, separating the laboratory areas from the living areas, returning to Earth in quarantine. That's going to take literally decades to plan it. And there is no early return. And there are physiological and behavioral changes that could happen to people that are stuck. This is a photograph of the ISS. And you can see they're floating around in microgravity, and they eat, they sleep, they play, they listen to music, all in the same space. And so essentially you're using humans as experimental subjects as well. So there's all sorts of questions you want to get. Next slide. Then we bump into other issues as well. For instance, what if we find ET while we're up there, microbial extraterrestrial life? Already for SETI principles said, what do we do if we discover life, if we get a message? from out there in the galaxy that says we're here. In the short term, what they agreed is the astronomers said we'll verify that it's a real message, we'll share the information, and we will not respond without consultation with the larger community. How will the world react? What are the psychological effects of finding and knowing that there's ET out there? That meaning might depend on different cultures or religions. It may have significance for some groups and others wouldn't care. And who beside the scientists should decide what to do? And there is no enforcement, in fact. We can't decide whether they're going to come here or not. So similar questions arise for microbial extraterrestrial life, although we'll probably have to deal with them sooner. We have to take an operational view and a long-term view and set up policies. Right now, there are no policies for what to do if we discover microbial life. Do we leave the astronauts up there? Do we make them stay out and not let them re-enter, much like we did with the cruise ships? Don't come to port because you may have a infection on the ship. Are we going to have different recommendations for if it's exploration versus settlement or tourism or resource use? What do we do? In fact, there are questions about whether you could reverse the contamination if you did get it cross-contaminated. And people are talking about, let's go up there with 1 million people. Musk is saying that now, let's bring people up and terraform, make these planets be something that we can go to. But if life exists up there, there raises other questions as well, not just legal or commercial ones. For instance, if we find life and it's different than life as we know it on the DNA chart of life, is that a second genesis? That's not a science question. That's a theological question. And so already there are ethicists and theologians who are asking, what would it mean to different religious groups if we found a second genesis? So the new view is that we have a biological universe and we need to broaden our focus. So we're not just thinking about living on Earth and dealing with Earth life, but what would it mean if we have a cosmocentric focus? We're thinking there could be life out there. What does that all mean? So NASA and the international community actually have conferences and take a kind of astrobiology, a medical focus, a legal focus, and there's a lot of progress that would surprise you. Next slide. Other possible issues ahead beyond the science and technology. Again, what are the plans and protocols and issues that would arrive if and when we discover extraterrestrial life? What do we do for the environmental questions beyond Earth? There are no laws right now. And just this week, Elon Musk has come out with a saying that it should be a free planet for him to go to Mars. Mars should be a free planet and forget the Outer Space Treaty. He's talking about commerce. He's talking about tourism. He's talking about questions of liability. They're going to bring you up there. What if they don't bring you back? So all these questions raise things that have to do with legal questions, ethical questions, and the issue we have is how far ahead do you have to change laws or think about laws? Nobody had anything with cell phones until recently. Nobody in the 1950s were thinking about that much about satellites and our cell phones. So you can see that a lot of these things come up as time goes on, and living in space would be one of those. Next slide. So to understand what we're dealing with and to think about Thanksgiving on another planet, we first have to address a lot of questions about living in a biological universe. Are there other organisms out there? And what would that mean about life as we know it, scientifically and otherwise? And what does it mean to set up policies, laws, and practices that would allow responsible and safe exploration? So you can see that there's scientific, technological, legal, societal, even theological and ethical and moral questions that arise when we're talking about this, as well as where you're going to get your turkey for Thanksgiving. Next slide. So the conclusions are, it's more than just thinking about Thanksgiving. Before you even think about Thanksgiving on Mars, you have to acknowledge that space travel is very complex. We would have to deal with long-term artificial life support versus on Earth, everything's free. The rain brings the water. The oceans let us go across with the winds and everything. We breathe just what's around us. But space environments are very, very harsh. And in fact, they're so harsh that already another set of things has to come up. We have to consider radiation. That's a really big problem, the highest problem that we have perhaps. Isolation and confinement, which we all kind of know now when you think about coronavirus and the isolation that we have, and that has behavioral impacts on people. Distance from the Earth, it affects our communication, our ability to get there, and lack of gravity. We do not know really what it would mean for someone to live in low or no gravity for more than months at a time or a year at a time. And the hostile closed environments that the astronauts have to live in, the changes in temperature, pressure, light, reuse of everything, those are things that we've never really had to flesh out completely. So we've got teams of people working, not just astronauts. We're exploring and discovering new things and making new things. And that information is changing all the time. So in the meantime, when people talk climate change or people talk new technologies and going to live somewhere else, enjoy your Thanksgiving, because it might not be like that on Mars. So I'd be happy to take questions from the audience and answer things. And if I can't get to all the questions, I'll be happy to send notes back to people and answer the questions later on.
That was a wonderful talk, Dr. Race. Very interesting to think about. Lots of interesting ethical questions as well.
Yes.
We had a few questions that came in. We have a few minutes left, so we can get to a few of them.
Okay.
The first question is, radiation and lack of an atmosphere on the moon and Mars are huge safety concerns for astronauts. Meteor impacts on the moon are another hazard. Any ideas as to what might reduce those hazards?
On the radiation one, you can do shielding, of course. And if you have a solar storm, even on the way to Mars, it could be a problem because now you've got that great radiation because you're beyond the Earth's magnetic field. So they even talked about making, I'll say a phone booth, it wouldn't be that small, but shielded areas. And so it's in the spacecraft, you can deal with the radiation en route, and then you'll have to deal with it on the surface when you get there. One article that I saw one time was fascinating. They suggested even using the astronaut's feces as shielding between the walls of the biodome that you would build up there. So nothing is wasted. Everything you have has another use.
That's interesting. I remember Dr. Pascali mentioning that in the walls of the ship going into space. So that's very interesting. If it works. How about the potential for more RNA life forms being discovered instead of DNA?
Now that one, you see there's molecular biologists that work with NASA as well. And so people that are working down at the cellular level and the nanoscale, all of those questions are possible. And if you found in astrobiology, the questions have to do, what is the origin of life? And what is the evolution and adaptation of life? And so if you had RNA, could you step into the DNA and then on up to the microbes and then to the invertebrates and the vertebrates? So that's one of the questions about astrobiology, is understanding possibility of RNA life forms. Look at the COVID is a virus. It can't replicate until it gets into a being like a human.
We have time for one more question. Someone asked, who would cover the expenses for folks trying to live on the moon or Mars?
Very interesting. Now, so there was an article today in Science News. I'm sorry, I was reading so many of these articles, but the article raised that very question. Do we want to have these things paid for by government? Or if you get into the commercial aspects of it, who's going to make the regulations that go along with it? And so right now, the early exploration, as you can see, takes on the order of, decades along. We're starting to supply the technology and do the testing and the early exploration. But at some point, if these settlements become human things and have a commercial value, shouldn't the commercial folks take it on? And again, here we talk about the length of time it takes. We're talking years to decades to longer. And honestly, I don't think that we'll be living as a human settlement on other planets like Mars for literally decades, many decades, perhaps even up to the end of the century.
Maybe a while before we celebrate Thanksgiving there, but very interesting to think about. And thank you so much for taking us on that journey. And it was very fascinating to learn about where we're heading and what might be possible in the future.
Right.
And thank you so much for taking the time to be with us. I think we're out of time now. And thank you to the SETI Institute for partnering with us on these wonderful virtual talks. Dr. Reese, that was a wonderful talk. Thank you so much for being with us today. And thank you all for tuning in. We have these programs every month. I know we have another one coming up in December with the SETI Institute, and at Chabot we have programming every Friday at 7 p.m. or Saturday evenings we have our live telescope viewings at 9 p.m. So tune in for those with our resident astronomers. And you can visit our website at chabotspace.org to check out any upcoming events that we have coming up. Before you go, be sure to click the survey link that we're going to be posting in the chat. And we'd love to hear your feedback on this event. And we hope that you'll join us for more events in the future. Thank you all so much. And we will see you next time. Have a great night.
Okay. Thank you very much. Happy Thanksgiving, everyone.